Okay, so I'll start off. Chris, in the meanwhile, just put in your email address and I'll mail it across to you.
Okay, thank you.
I used to work in IBM long time back. So which division of IBM are you in?
Information management is software group.
Okay, so I was in GBS.
Okay. Yeah, I get trained fairly frequently, so.
And we have an Australian data set as well.
That looks appropriate.
Okay, here we go. Right, so what I'm going to start off is I'm just going to give you a brief background for about a couple of minutes on the theoretical part of time series so that we build a little base and then move on to how to do it on Excel as well as SPSS. So any background in time series, Chris?
No, not a lot. It's been a while. I did do some as part of my operations research component of my degree, but that was a little while ago. I haven't touched it since.
Okay. Okay. Anything, Gaurav, Malik Arjun, anything?
Nope. I don't have any background.
Okay, so I'll first start off with what's the difference between a data set with which we worked last time, let's say for which we did a logistic regression on, and how does the time series data set differ from that? You saw the data set on which we did a little bit of credit scoring. Now, how does the time series data set differ from other data sets? What is the basic difference, Gaurav? Before we move into the assumptions, what is the basic difference in the data set?
Well, in the last webinar, we had the credit reporting Excel sheet. It had the categorical and the numerical values. And
correct. Right. Typically, what time series data set, how it differs from the others is that a time series data set is a univariate series in which we have repeated measurements over intervals of time of the same thing. Right? For example, I'm going to take the temperature of a particular room and I'm going to measure the temperature of the room every 5 minutes and I'm going to note it down on a column. Now that is also a data set. Now that particular data set is specifically known as a time series data set. Right? So how do you define a time series data set definition? Again, if you had to make a definition, how would you make it now? Malik Arjun, try to give it a try. How would you define a time series data set? Anybody? How would you go about defining a time series data set?
Hello.
Yeah, hello.
Yeah, hello. I think what I understand that time series data set is something which where the data is collected over a period of time, associated with time. What I mean to say, for example, that if you talk about Sensex data set, right, and if you are collecting a particular share price each 5 minutes or each 1 hour or after each 1 minute, then that would be a time series. But if you collect share price randomly in a day, that would not be time series.
Correct. Perfect, right? Now the basic definition that we can come up with time series data set is that we take any measurement, any particular measurement in an ordered format over a period of time. Right? So, can you all just put the mic on mute till the time you have to, say something so that the disturbance gets crossed out. Right? So, whenever you have to say something, just unmute it and you can interrupt me anytime. Otherwise, let's keep it on mute so that the interference doesn't get too bad. Right? Now, what we can say about time series, as we can say, is that it's a representation of a variable over a period of time. That's correct, Malik Arjun? Right? More specifically, it is the measurement of the same thing at equal intervals of time, right? So that also holds one of the first assumptions of doing time series analysis, that the data that we are working with should be equally spaced over time. For example, if we are working with stock price data, it should be day-on-day data or closing day or opening day data. If we are working on, let's say, sales data, right? I can now do sales analysis which is day-on-day sales. I can do analysis which is week-on-week sales or month-on-month sales. But what I cannot do is I cannot mix up data from day-on-day and week-on-week together and do some analysis on that. That cannot happen because that is going to adjust or that is going to change the behavior of a time series. Right? The second assumption of time series analysis that we do is, now this is one of the very important assumptions, which is patterns of past should propagate into the future. Right? I.e. the time series should not display a random walk. Right? Now I have a question over here. What do we mean by a random walk? What's a random walk? This particular phrase over here. What's a random walk? Anybody?
I think, may I?
Yeah, go ahead.
Yeah, random walk is something, if you have heard about Brownian motion.
Brownian motion is a random walk?
Brownian motion is a random walk. Oh. I may be wrong.
Yeah, but what is the definition of a random walk? Arup? Yeah, Arup, want to give it a try? What's the definition of a random walk? Okay, Chris, how about you? Hello, yeah, Chris? Okay, so I'll cover that. So a random walk is typically any series in which the next direction of the series or the next step has got no correlation or no dependency on the previous value. For example, the value of the series at ft is completely independent at t minus 1, t minus 20, t minus 3 and so on. Right? So does that make any sense now, Chris? Hello? Yeah, Gaurav, are you there?
Here, I was on mute actually.
Yeah. So let's imagine I've got a series, right? And it's in the future, it's going to take some direction. It's going to go up, it's going to go down, or something like that, right, Gaurav?
Yeah.
Right. Now, typically, series have got dependency in the past. That is known as serial dependency. Now, any particular series in which the direction, or let's say the next value, has got nothing to do with the previous values of the series. Can I say that this particular series is now independent of the past?
Yes.
Right? In that case, that particular series is defined as a random walk, where the current or the future value of the series is completely independent of the past value. That particular series is defined as a random walk. Right? If our time series is displaying a random walk, right? Now this is very important. Everybody please pay attention. That this is a very important, let's say, assumption. If the series is displaying a random walk, i.e. the current or the future values have got nothing to do with the past value, in that case we cannot do time series analysis. Right? Time series analysis is possible only when patterns of past are going to be propagated into the future. There is serial dependency in the series. Otherwise, we cannot proceed. Right? Otherwise, you can never, let's say, try and forecast a random walk. Right? So that brings into question: does stock price market display a random walk or not? Anybody? Arup? Do stock prices display a random walk? Yeah, Malik, your mic is working. Okay, anybody else? Swadhin? Random walk now?
Yes, I understand now. I think share price are affected with so many factors. So not exactly we can say that they go with random walk. What I understand.
Correct, right? So they lie somewhere in between, but they are notoriously difficult to predict. If someone could predict, they would make a lot of money, right? But their stock market prices are typically defined in the short term as showing a very random nature. So we try different things over there. We try art and large models, which try to define the randomness rather than try to figure out where series is going, right? How the hedge markets, the hedge funds work. They try to forecast what is going to be in the next few seconds itself, right? So very very difficult over there. But typically, the major assumption that we are talking about over here is that a pattern of past needs to be identified. There needs to be the assumption that this particular pattern of the past will continue into the future, and then we forecast that particular pattern into the future itself, right? The third assumption of time series is cannot be used to predict random events, acts of God, etc. Right? Which is again a extension of the second condition itself. That patterns of past will propagate into the future, that automatically means no random walk. Therefore, no random events can also be predicted. I.e., we can't predict when the next storm going to hit, when the next tsunami going to hit. Right? What we may be able to predict is what is the impact. Right? Predicting the impact of an event is different from predicting the event itself. Okay? Let's move on. Right? There's a data set which is retail2.xls. Let's
just summarize what you just mentioned. If I understood correctly, the share prices or share market or stock market is a random walk.
No, I didn't say it's a random walk. It's actually it is approaching a random walk.
Is that correct?
Right. Every day you can, time series modeling is used effectively on the time series modeling is used extensively on stock market data. It is used, right? But it's not very successful, as I mentioned earlier.
Okay.
Precisely because it shows a very high nature of randomness. Okay. So let's continue. I want all of you to open the retail sales data set. Right? Has everybody opened this up? Right? Look at this data. So I've got data which is sales, and it's a sales of month-on-month data set. Right? Looking at this data set, can I say is this a random walk or is there some pattern in this particular data set? Arup, do you have the data set? Yeah, Swadhin.
I'm
this particular data set, is this a random walk? Yeah, is this a random walk?
No, it's not random. What I see, because the data is distributed between 12 to 15, something like that, and some values are not repeating. But I don't find that that's
one of the easiest ways to figure out what the series is behaving like is we must plot the series. Right? A visual check is still a very, very important check. There are lots of statistical checks as well. But the first and the easiest check is that we must plot the series. So I'm going to plot this. I'm going to go to, can you see my Excel screen? Okay. I'm going to select the sales data set. I'm going to insert a runtime plot or a run sequence plot. And so this is what the series is coming out like. Right? Now looking at this, so Gaurav, is this a random walk? Or is there some pattern in this particular series?
It's a pattern in the series. There's a pattern in the series, I guess.
Yeah, so what's the pattern? There is a pattern in the series. Can the series be forecasted into the future?
Yes. I mean, looking at the graphs that you just made, it seems that every interval of like 11
there is a repeating component, right? And I can try and forecast this into the future with some level of accuracy. Right? So this is where we now move into how do you go about doing forecasts or how do you go about modeling a time series, right? So the first step that we do when we are working with time series is we do the decomposition of time series. Right? This is where we're going to work with decomposition of time series. So what does decomposition of any particular thing mean? What does decomposition mean? What do we understand by decomposition? Sorry?
No, I don't know.
Okay, Malikarjun? Anybody? Arup, are you there?
Basically it should mean breaking into pieces.
Absolutely. We're going to break a time series into its constituent pieces, right? Right. Now, every time series data set is typically divided into 4 components, right? So, the series that we see over here, this is the same series in this particular diagram as well, right? The 4 components that we are interested in is the trend, the seasonality, the cyclic, and the irregular component, right? So, we're going to talk about the trend components first, right? What does trend signify? Trend is the long-term progression of a series independent of its short-term fluctuation. Right? So can I say in the long term where is the series headed? Does the series have a trend? And if so, what is the trend? So Arup, what's the trend in this particular series?
This is increasing.
Right? So I've got a linearly increasing trend, right? If I cancel out the short-term fluctuations in the series, these short-term fluctuations which are going up and going down, right? If I cancel it out, I can see that there is a long-term going up trend, right? A linearly upward trend. Right, Arup?
Yeah.
Right, Gaurav?
Yeah. Yeah.
Yeah, Gaurav, can you see that or can you detect that there is a long-term increasing trend? So if I look at this particular point in the graph over which we have removed the short-term fluctuations, right? In this particular panel, what we've done is we've removed the short-term fluctuations and we've got a linearly upward trend over here, right, Gaurav?
Yes.
Right? So that is the trend component of the time series. Then next component is the seasonality. Right? What do we mean by seasonality in time series now? Swati, take a guess.
Yeah, I think seasonality means because of seasons, because of maybe winter effect. If you look at the ice cream sales, they're affected by seasons, and winter that's down in summer. So there's a particular pattern because of season. That is known as seasonality, I think. Okay.
Right? Seasonality may not be because of season, it could be because of a fluctuation, a regular repeating pattern, right? Typically, if I look at, let's say, sales at a pub, right? If you run a pub or anything, you look at sales over a week, over a month or a couple of months. What you would observe is that every weekend the sales goes up. And then on Monday they come down again. Again Friday, Saturday, Sunday the sales goes up and then they come down again. Right? So I observe this regular repeating pattern, right? And what is the length of this pattern? What would the length of this particular pattern or this particular season be?
Length would be, in the spot example would be a week, maybe, and
so it would show a 7-day seasonality, right, Swati?
Yes.
Right? In that particular case, I would see that sales shows a 7-day cycle. If I look at the sales of gold or let's say sales of any other product in India, I would see that they spike during the Diwali season and then they again go down. Right? Or if I look at sales in North America, I would see that sales spike during the holiday season, that is in December, and then they come down again. In that case, the seasonality I am showing is of 1 year or 12 months long. Right? So the definition of seasonality is that if our series is showing a regular repeating pattern at equal intervals of time. Right? So that is known as seasonality. So looking at this particular graph, now Swati, does this graph show a seasonality?
Yeah, it's shown. Yeah, it is shown.
It shows a classic crest and trough design as is repeating at equal intervals of time, right?
Yes.
And I say this is a regular pattern repeating at equal intervals of time. Right? In this case, the series is also showing or displaying seasonality. There is a seasonal component of the series, right? And this particular pane in which we have broken down the seasonal component alone. Correct? right? So out of this, so how long is the season in this particular data set? So this is month-on-month data, right? Perfect, Arup. So this is month-on-month data. So we have got a yearly seasonality over here. The length of the season is 12 months, right? So after every 12 months, the pattern repeats itself, right? So we've broken down into two components. One is the trend, which is a long-term progression of the series in which we have cancelled out the short-term fluctuations of the short-term seasonal impact, right? So that is the pure long-term progression of the series, which is displayed by this line alone. Then we have the seasonal component, which is a repeating pattern at equal intervals of time. Right? At this point of time, is everybody clear about trend and seasonality in a time series? Gaurav, are you clear? Yeah, Gaurav, are you clear regarding trend and seasonality?
Yes, actually, I'm hearing a lot of background noises as well, and sometimes the voice is getting. It looks like there's a moment of silence, and then.
Okay, I think probably something will do with the net connection. Right, so at this point of time, are you clear regarding trend and seasonality? Okay, so we'll leave it that. Malikarjun, I think you are also clear, right? Now, the next component is the cyclic component of a series. Cyclic component is typically the fluctuations caused by economic cycles, i.e. boom followed by bust, etc. Right? And typically we do not try to model the cyclic impact of time series unless we are working with econometric data, that is, GDP data, etc. On short-term time series which are over a few months or a few years, typically the cyclic component doesn't come into play. A cyclic component will come into play over a period of 30 or a 40-year progression. Right? Now, cyclic is different from seasonality because it is caused by the economic fluctuation. Right? Now, this would happen over a very long period of time. It's not subject to short-term. By short-term, I mean a couple of years, etc. over here. This typically comes into play when you're working with 20, 30, or 40 years of data. Right? I.e., a recession followed by an inflation, right? A boom followed by a bust, etc. That's the cyclic component. Now, the difference between cyclic and seasonality is one is that seasonality is a repeating pattern at equal intervals of time. Now, cyclic is also a repeating pattern, but it may not occur at equal intervals of time, and the time intervals are very, very large in this particular case. Right? So, Swadhin, are you clear about the difference between seasonality and cyclicity in the series?
Yes, I'm clear.
Right? So, typically, we are not bothered about the cyclic impact unless we are working with the econometric data. Right? Lastly, what we have is the irregular component or the noise of a series. What do we understand by noise, Swadhin? Try to give it a guess.
Noise is something, or irregular component, something which suddenly some happening abrupt the event. Maybe it may be any volcano, something like that, or curfew, putting the curfew or political trauma, change the share prices movement, something like that. That something happens suddenly.
Typically, yeah. So you're close, but not. It's not regarding a random event, right? Okay. Irregular or the noise component is that part of the series which cannot be broken down into the other components, trend, seasonality, and cyclicity. It is irregular. It has no pattern, and it cannot be predicted.
Okay.
Right? So even if I define the trend and the seasonality, there is always some leftover part left in the series, right? Some random fluctuations which cannot be accounted for. Right? So that is known as the irregular component or the noise component. Right? So what should be the statistical properties of the noise component? Anybody? Arup?
Yeah.
What should be the statistical properties of the irregular component of the series? Give it a try if you can.
Statistical property.
Yeah. Or what should be the mathematical property of an error term? Anything.
Average should be 0.
Average should be 0, yeah. So I can say that positive and negative fluctuations should cancel out each other.
Right. Yeah.
Right, Arup? The other is that there should be no autocorrelation. So I cannot look at the previous fluctuations and predict the next few fluctuations. Right, Arun?
Okay.
Because if I can look at the previous fluctuations and predict the past, the future fluctuations, that means there is a pattern in the noise component, right? Therefore, it is not irregular. Correct, Arun?
Right.
Right? So it should be IID. So more on IID later. Typically, it should be unpredictable. The random error or the noise in the series which has no predictive power, it cannot be predicted or it cannot be fitted in. Correct? So at this point of time, is everybody clear regarding the decomposition of the series? So what are the four components, and let's try to give it out. So Gaurav, can you quickly recap the four components of a time series?
So first was the seasonality, where it repeats at equal intervals of time, and then there was like the last point that you mentioned about the irregularity, like random events can happen anytime. I mean, that's called as error or noise.
Yeah. So let's start off again. So the first is the trend of the series, right? So what does the trend signify, Gaurav?
Long-term progression. Okay.
Correct. The trend is the long-term progression of the series. Is it a flat series? Is it going up? Is it going down? Is it exponentially rising? What is happening to the series in the long term? When I cancel out the short-term fluctuations in the series. Right? Can everybody else just put their mics on mute till the time they have to speak or they have a question? Right? All of you, if you look at your options, there's a mute button over there. You can just put it on mute till the time you have a question. Just unmute and then ask me the question. Right? So, one is the long-term progression. Yeah, Gaurav? Yeah, Gaurav, you can unmute now since I am asking you. Right? So, Gaurav, I've got the long-term progression of the series within the trend component. Right? Then what do we mean by the other components? Can you quickly recap? The other components are?
So the second component was seasonality. We saw that in our retail Excel sheet, there was periodic ups and downs. So it was a repetition.
So what's the difference between seasonality and cyclicity? The difference between seasonality and cyclicity in the series?
So seasonality was happening at equal intervals. And cyclic, the example that you gave here is by fluctuations caused by economic cycles. So they are.
Correct. It may not happen at equal intervals of time, right?
Of time, correct.
There is no, so if you look at previous cycle, if the previous economic cycle is 10 years, there is no guarantee that the next economic cycle will also be 10 years. It may be 30 years, it may be 5 years.
Right? It's not periodic.
It's
okay.
It's not it is periodic, but the period does not remain the same.
Okay.
Correct.
Okay.
So in seasonality, if we are looking at a weekly seasonality, throughout the series, the length of the season will always be 7 days. It can't be that it is 9 days in one and then 6 days in the other part of the series. It has to be regular at 7 days interval. Clear?
Okay. Yeah, clear.
Yeah, Gaurav?
Yeah, it's clear
and
now.
The irregular component is that part of the series which cannot be explained by any particular model. It is the random error or the noise in the series, and it is typically has a mean of 0, i.e. positive and negative fluctuations will cancel out each other, and there should be no serial or autocorrelation in the series, i.e. looking at the past, I cannot predict the future in terms of the irregular component itself. Okay? Right? So looking at this particular series that we have, how do we go about extracting the trend? In this particular graph, you can see this trend has been extracted. Right? From the series, we have cancelled out the impact of short-term fluctuation. Right? And this trend has come out like this. Right? How do I extract the trend? Right? Everybody please move on to your Excel sheet. This is the change data. Right? How do I extract the trend from this particular series? Anybody? Any ideas? How do you extract trend? To extract trend, what we must do is we must cancel out the short-term fluctuation of the series, right? Correct? So how do I do it? Anybody? Swati? How do I extract the trend from this particular series that I have?
So I don't have any idea.
Okay, Gaurav? Malikarjun, Gaurav, any idea? Okay, so
No.
one particular method that we can use is moving averages. Right? Simple moving averages to cancel out the short-term fluctuation. By moving average, what do we mean is, let's start it with a simple moving average. I take, let's say, 6-month moving average. I just take the average of these series like this. And the next average will, how will the next average be calculated? I have moved the window down by 1 point, right? And if I want to move it over here, it goes down by 1 point. So now can you see why is it called a moving average window? Yeah, Gaurav, does that make sense?
Yeah. One at a time. I mean, you're moving the window by 1. And then
So I'm taking the average of the series and using that. Now let me plot both of them together and see what is happening. Let's see if it cancels out the short-term fluctuations or not. Right? So looking at the red line, can I see that it has cancelled out the short-term fluctuations?
yeah. Yeah.
Yeah, sorry.
Yeah.
Can I see that the trend has been extracted?
Yes.
Right? I can change the window of the average also. So in this particular case, what is the window of the moving average window? How long is the window? What is the length of the window in this particular methodology that I have taken? Yeah, so can I say it's 6 months window? Yeah, sorry?
Yeah.
No, you are taking 8 periods at a time to take a simple moving average. So I think it's 8 B2 to B7. No, it's 6. It's 6. Yes. It is a 6 months window.
Right? I've taken B2 to B7.
Yes.
Yeah, so I can change it if I want. Let's say I wanted 8. Right? If I wanted 8, I can take 8 also, right?
Yes. I got it.
So let's have a look. If I change it to 8, what's happening to the series? Everybody please look at the graph. I'm changing it to an 8-month window. So what happened to the series? It became more smoothened, right? Right? Now look at this. I go from here to 6 to 8 and the series becomes more smooth, right? So typically the longer I average I take, the more smoothened the series becomes. Right? So this was the moving average window of trend extraction. The other is weighted moving average. Right? So what's the difference between simple moving average and weighted moving average? Anybody? Yeah, sorry?
Yeah, weighted moving average is something where you are giving weight to the different time by taking moving average.
Right? Right? In simple moving average, when I take this idea, right, all of the previous 8 months have equal weight, right? Right, Swati?
Yes.
Right? So period 1 has the same weight as period 8 also. Right, Swati?
Yes.
Right? In weighted moving average, what we say is that the value of the series which are closer in time to right now are given higher weightage. The older part of the series is given lesser weightage. Right? So that is how we do weighted moving averages. Right? So what is the advantage of using weighted moving average over simple moving average? Gaurav? Yeah, Gaurav?
I guess the weighted moving average will be, the curve will be more smoother. I don't know. I guess it's a more appropriate representation.
Right? So what will happen in weighted moving average is that the current value of the series is given higher weightage and older value of the series are given lesser weightage, so our series is more accurate. Right? One drawback of simple moving average is that when I am smoothing the series at time period 8 over here, right? If you look at this particular time period, Gaurav.
Yeah.
Yeah. So when I am smoothing the values at time period 8, now time period 1 has the same impact as time period 8 also. Right? If I look over here, time period 1 and 2 have the same weightage as time period 7 and 8 in smoothing the series. Right? But it should be that time period 8 should have a higher impact as compared to time period 3, 2 and 1, right?
Correct, yeah.
Right,
That's the current event. That's the current.
Right?
Okay.
That the current value of the series should have a higher say in saying what should be the smoothed value of the series as compared to the old values of the series, right?
Yeah. Same.
Right? So to ensure that happens, we sometimes go for weighted moving averages. Right? But these are, so moving average methods are rarely used. The ones which are used today, they are known as exponential smoothing. Right? And exponential smoothing, anybody's heard of this term exponential smoothing? Yeah, anybody's heard of the word exponential smoothing in time series?
I've heard a lot but don't know what exactly it is.
Right? So I'm going to explain exponential smoothing using a formula. Right? I want everybody to be doing this on their systems as well. Right? Let's open up your Excel sheets and try to follow me on screen. Right? I'm going to create another series called exponential smoothing. Let's go to start off with the period 2 itself. It says this value of the series is, let's say, 0.2 times. Right? So the first value of the series is the same value that we have over here. Now this value of the series is going to be, let's say, 0.2 times the previous value of the series plus 0.8 times the previous smoothed value of the series. And then I'm going to drag this formula down. Right? Can everybody please do that? Right? So just put this into the formula or the equation that you have. I'm going to put it in chat. Right? Everybody please do this on your Excel screen. Done. Gaurav, is it done?
No, I'm still doing. I guess. Wait a minute.
So I'm going to explain this formula right over here. Everybody please it's a very simple formula. What I'm doing is I'm going to show it again. Right? Let's do it again. Please pay attention on my screen itself. The first value of the smoothed series. Now everybody please pay attention. Yeah, Vinod, are you there on the call? Okay, let's put it on mute. All of you just put it on mute. I'll ask you to unmute it later. Right? So the first value of the series is going to be, the exponential series is going to be as per this itself. Right? First one mute.
Yes, I'm on mute.
Okay. Right? From this point onwards, what I'm going to do is I'm going to use this formula that st is alpha times x of t minus 1 plus 1 minus alpha times s of t minus 1, where alpha or a is the smoothing factor, and it's going to take a value between 0 and 1. It can only be between 0 and 1. So I'm going to put a equal to, let's say, 0.2 over here. Right? I'm going to do that. This time the series is going to be 0.2 into x of t minus 1 plus 1 minus alpha, which is 0.8 into the previous smoothed value. So pay attention on the screen. This is going to be 0.2 into x of t minus 1. X of t minus 1 is this one. Plus 1 minus alpha is 0.8. 0.8 into the previous smoothed value, which is over here. And then I'm going to drag this formula down. Right? And I get my whole smoothed exponential smoothing series over here. Right? I want everybody to do this on their Excel sheets right now. I'm trying to do this. Anybody has a problem, let me know. Yeah, if you have any doubts, queries, you can unmute and ask me. So, Swadhin, is it done?
Yeah, I can do that.
It's done? Okay, done. Gaurav, have you done it also?
Yeah, it's done, Karan.
It's done,
Yeah,
right?
I was able
Now,
to do
this
that.
is also now what I'm doing is, right?
So how did
so
you?
over here, I have also extracted the series, right? Yeah, how did I?
That graph that you made. This graph.
Okay, yeah,
You
just
use the
have a look
product
at
sales
this.
and exponential.
Right? I'm just going to select B and C, and then I'm going to insert the graph.
Oh, I see. Okay. Thank you.
Right? So as I can see now, that the short-term fluctuation in the red line has been cancelled out, right? I'm only left with the long-term fluctuation, long-term trend of the series. Let's have a look at this. Third line, right? So there is some fluctuation, but primarily I'm left with the long-term progression of the series over here. Right, Gaurav?
Right.
Yeah, Gaurav,
Right.
can you see this?
Yes.
Right? So now what will happen if I change the value of alpha? Right? Alpha is the smoothing factor, it can range from 0 to 1, right? Let's change the value of alpha from 0.2 to 0.6. So can you tell me how the formula is going to change here, Gaurav?
So 0.3.
If I change the value of alpha from 0.2 to 0.6, if I change it, so what's the value of alpha going to be like? How do I change this formula?
So it'll be 0.6 times B2 plus 0.4 times C2.
Yeah. So let everybody please do this. And look at your screen, what is going to happen. So look at my screen first. I'm going to drag this formula down so it changes the smoothing factor. Right? So what's happening to my smoothing series? What happened to my smoothing? Anybody?
I think it is less smoothing, less smooth than the previous one.
Less smoothing, right? Now I change it from 0.6 to 0.1. Right, let's change it to 0.1. So this was 0.1 B2 into 0.9 C2, right? And I got it. So how does this look like now?
Probably looks like increasing trend. It's smoothing now.
More smoothing, right?
Yeah.
It's more smoother than before, right?
Yeah.
Right. So, Swadhin, what happens to the smoothing series if I change the smoothing factor? If I increase the value of alpha, what happens? If I decrease the value of alpha, what happens? Yes, Swadhin, you can unmute and try and answer this.
Yeah, when we increase the value of alpha.
Yeah.
Hello. Yeah. When we increase the value of
Yeah,
alpha,
go ahead.
it is less smooth. It has become less smooth, similar to the original data. But if we decrease the value of alpha, it become more smooth.
Perfect, right? So we can control the amount of smoothing by changing the value of alpha. Right, Swadhin?
Yes.
Yeah. So Vinod, are you there in the call? Okay. So now Arup, are you there?
Yes.
Okay, Vinod, so I have a question for you. Now, why is this called exponential smoothing?
I'm not
Vinod,
sure.
can you
Yeah. Is it
give it a try?
because? Yeah. Is it because
the function used approximates some kind of exponential function?
Perfect, it does, but how? Because of the formula perfect molecular. So what I'm going to do, so Vinod, what I'm going to do is I'm going to open this up in the notepad itself, the function. So let's have a look. Right? So ft is going to be, let's say, alpha times x of t minus 1 plus, as it said over here, it's 1 minus alpha times s of t minus 1. So what is s of t minus 1 if I want to replace s of t minus 1? So Gaurav, what is s of t minus 1 over here? Gaurav, can you unmute?
Oh,
Yeah, Gaurav, can you open up s of t minus 1 for me? So what is s of t minus 1 now?
well, s of t minus 1 will be a of x of t minus 2.
Will be a times x of t minus 2 plus 1 minus a
times x of t minus 1.
s of t minus 3 or t minus 2 over here, right? Again,
Minus 2, yeah.
right? So if I open this up, so it again becomes equal to a times x of t minus 1 plus, and now it's going to become a square times, right? So this becomes a square because the other part will cancel out each other. So this becomes a into a of x of t minus 2, right? And if I open it up again further and further, it becomes a into a of x of t minus 3 and so on and so forth, right? Right, Gaurav?
Yeah.
If I open up this whole algebraic equation and solve it, this is what the exponential smoothing series is going to come up like. So this becomes, if the value of a alpha is going to be 0.6, which is now 0.6 into t minus 1 plus a square is 0.36 into t minus 2. Then third is again 0.36 into 36 is going to be 0.216.
Correct.
Right, into t minus 3. So I can see now the weights against each of the lags of the series is starting to decline in what format? How is it declining, Gaurav? I am assigning, so essentially what I am doing is, the current value of the series is determined 60% by the nearest value, 36% t minus 2, 21% from t minus 3 and so on and so forth till the last value, right? How are these weights declining against each other? Yeah, Gaurav, how are the weights declining? Perfect, Malik,
So,
they are declining exponentially, right? Right, so Gaurav, let's have a look over here. I'm going to show it to you in a graphical format, right? If I'm taking 0.6 as the factor, so square becomes 0.6 into the previous value of the series. So isn't this how the weights will go down? Right, Gaurav? And if I plot them on a graph or on a bar chart, right? So how are the weights going down? Add a trend line here. So add an exponential trend line, right? Can I see now the weights against each of the parts of the series are declining exponentially?
yes. Yeah.
Right? So when I look at this particular graph, I can say that this value at 38 is given the highest, let's say the highest weight. Then the next particular graph, next particular point t minus 2 is given there, the next highest and so on and so forth. Right? The weights start to decline exponentially as we go back into the series, right?
Correct. Yeah.
Right, Gaurav?
Yes.
Right? So at any point in the time series S, let's say even at this point at a period equal to 37, right? This particular series, this particular smoothed value is a function of all the past values of the series, except that the most recent value have a higher weightage and the oldest value have a very low weightage. And this weight starts to continue to decline exponentially now. Right, Gaurav?
Yes.
That makes sense now?
Yeah.
Right?
Yeah.
Now, in this exponential smoothing, what is the length of the window in which we are going? How far back do I go when I calculate the value of the smoothed value of the series? How far do I go back?
You went back by just one value. By the previous one.
No, I go back all the way, right? It's a recursive formula, Gaurav. I'm going all the way. In moving average, I was going back only the window, either 5 months, 6 months, or 7 months.
Oh,
Right, Arup?
Yeah.
Yeah, Arup, are you there?
Yeah, I'm there. Yeah.
Right? So you understand the difference. That in moving average, I went back only 6 months or 8 months, but in exponential smoothing, I'm going back right to the beginning of the series every time I calculate the smoothed value.
Exactly.
Right? So when I do that, what happens is that the series uses an exponential declining formula. Right? Now, Swadhi, were you able to understand why is it called now exponential smoothing?
Yes, perfectly.
Right? And the difference between a moving average window and exponential smoothing?
Yes.
Yeah, Swadhi? So which one is more sophisticated?
I think exponential smoothing is
So
more
which one is more
sophisticated.
sophisticated? Perfect, right?
Exponential
It is
smoothing.
more sophisticated. It removes. It is more sophisticated. It removes the problem of determining what should be the length of the window. We just change the smoothing factor throughout over here. Right? So this way I can extract the trend now. Right? So looking at this particular smoothed series, how do I use it for forecasting now? I want to do a forecast. Right? I'm going up to period 144. Right? That is 12 years of data, but I want to forecast after this as well. How do I do the forecast? Right? All of you can you just go down to the end of the series and generate a 12-month forecast for me. How do I do a forecast? Right? If I do this over here, I get a 1-month forecast. But after that, I don't get any forecast at all because it is continuously referencing empty cells, right? Right? So the question for you, Arup, how do I use this for forecasting? So Arup, try to tell me, how do I do a forecast over here?
You forecast for 1 month and then put it back in the original data. And then it keep continuing.
If I forecast this, right? When I do a forecast over here, it is going to an empty month, right? So how do I do this?
You can put the earlier forecasted value to the original data sheet.
Yeah, so since this was the smoothed value of the forecast, this cell itself.
Yeah.
Right, Arup?
Yeah.
But the problem is when I start doing this, right, my forecast essentially comes out to be a flat line. Right? So if I look at this particular graph now, Arup, can you see the forecast period is essentially a flat line? It is a flat line, right? Right, Arup? Right? Right? So till the point it is fine, but beyond, when I want to do forecasting, right? Now this is where different kinds of exponential smoothing comes into play. So I'm going to do a status check now. Does everybody understand the decomposition of time series and exponential smoothing to recover the trend of the series? Arup, Gaurav, are you clear?
Yeah.
Yeah.
Right? Swadhi, you are also clear?
Yes.
Right? So we have extracted the trend part. Now the problem was that how do I extract the seasonality part? So I'm going to go to the forecasting part later. We have already seen that for forecasting we probably have to do something very different from here. Right? The forecasting part is not working out yet using exponential smoothing, so we'll come back to it later. Right? What we've done now over here is we've extracted the trend separately. How do I extract the seasonality of a series? Anybody, any idea? Right? We're talking about the decomposition, right? If we go back over here, we have to decompose the series. So trend part we have extracted using the exponential smoothing. how to extract the seasonality now? Mallikarjun, Swadhi, anybody? How to extract the seasonality? Any ideas, Arun?
You need to understand to realize the period actually.
Could you elaborate a little more? I didn't get it.
I will need to find the period first. I mean in this case it is 12 months. So for what period the things are repeating actually.
It's repeating at 12 months, right? So what I want to do is I want to extract in this particular diagram, right? This was the original series that we have, which is the same series that we are working with, right? Right, Arun?
Yeah.
Yeah. So over here the trend has been extracted separately, and we know that we can do this using exponential smoothing. Right, Arun?
Yeah.
Right? Now this part shows the seasonal fluctuation which has been extracted and kept separately. Right? So how do I get this fluctuation out? How do I extract the seasonality? Right? Can I just subtract the smoothened series from the original series to get the seasonality? Can I simply do this? Yeah, Roop, so if I plot this, what will this give me?
Okay.
Right? Is this giving me the seasonal fluctuation around the series itself? If I do this, am I not getting the seasonal fluctuation around the series itself?
Exactly.
Right? So Gaurav, does this make sense to you?
Yeah, I can understand now.
Right? Right? So I've extracted the seasonality and this is the trend part. Right? I can say that this is the trend. If I subtract the trend from the original series, I should get the seasonal fluctuation. Right, Gaurav?
Yeah.
So can I say that I've got now, I've captured the trend and I've captured the seasonality separately for both of them. Right? So this is my trend part and this is my seasonality part, and I've extracted these two components from the series using exponential smoothing itself. Clear? Arun, does that make sense? Mallikarjun, any doubts till now? Swati, any doubts till now?
No, not at all.
No, I
Got
just
it all perfect, right? Now, yeah, go ahead.
Yeah, I think in this seasonality also the error is also there because
Error is there, right? You are right. The error component, we'll worry about the error component later.
yeah, error as well as the other
Right? Because we can't identify the error that. Yeah, error will come to a little later. But prima facie, given a series, on Excel, we should be able to extract the trend and seasonality, right? Given a series, we've been able to extract the trend and seasonal component out from the series, right? Right, Arup?
Right.
Right? Now we come to the part of how do I forecast it. Once I've extracted these two components, can I forecast the trend separately? So Arup, just try and follow me over here. Right? Once I extract the trend, can I just look at the trend and do some kind of regression and extrapolate how this trend is going to go out in the future? I can do that? Right, Arup?
Yes.
I should be able to do that. And now looking at the seasonal component alone, I should be able to forecast the next seasonal fluctuations also. Right, Arup?
Yeah.
And to get the forecast, then can I integrate these two parts together to get an integrated forecast?
Yeah.
Yeah, Arup?
Yeah.
Right? So what I'm saying is, that I look at the trend part alone and I extrapolate the trend. I look at the seasonality alone and I extrapolate the seasonality. Then I integrate these two together and I extrapolate or forecast my time series with both the trend and seasonal component together. Right? So Swadhi, does that make sense to you? Swadhi?
Yes, I understand that.
Right? So do you understand now why we studied the decomposition of time series? So that we could decompose it into its individual components, forecast the individual components alone, and then integrate them back together to get the forecasted series.
Yes.
Right, Swadhi?
Yes.
Right? Does that make
I
sense?
got it.
Okay. Gaurav, any doubts? Osama, nice to see you here. Any doubts till now?
No, it's clear. Clear to me.
Okay. Perfect. Right. Now we're going to get into the types of exponential smoothing that we can use. Right. Typically, there are three types of exponential smoothing. One is known as single, or they are simply known as single exponential, double and triple exponential smoothing. Now, as we saw, when we were forecasting, what happened to the forecast? We got a flat or a stationary forecast, right? So, Gaurav, this question to you. Yeah, Gaurav, you can unmute. So, Gaurav, are you there?
Yeah, I'm here, sir.
Yeah, Gaurav, I can hear you. So in single exponential smoothing, we saw was that when we start forecasting, we get a flat trend now. Right, Gaurav?
Yeah.
Right. So how do I get if my particular series is showing a linear upward or a downward trend? So can I say that this particular series is showing a linear upward trend?
Yes.
This is not a flat trend, so I don't want a flat forecast. If my forecast is coming as a flat line, that is not correct. Right, Gaurav? This line has got some slope and I need to capture that slope. Right, Gaurav?
Correct. Yes.
Right? In that case, we will go for double exponential smoothing. Right? What do we mean by double exponential smoothing? Is that we use two smoothing factors or two smoothing passes. Right? And this is used when we have either a linear upward or a linear downward trend. And when do we use triple exponential smoothing? When there is some kind of a non-linear behavior like exponential or parabolic or a logarithmic behavior to capture, in that particular case we go for triple exponential smoothing. Clear? So there are three kinds of exponential smoothing techniques. The one which I showed you on Excel was the classic single exponential smoothing, which is used to capture flat trends. When do we use double? When we have a linear trend to capture, and when do we use linear? Triple, when we have a non-linear trend to capture. Right? So now looking at this, Arup, which type of exponential smoothing should we be going in for? Yeah, Arup, are you there? Yeah, Arup, you can unmute.
Okay. So it's not clear. Can you hear me? Hello?
Yeah, Arup, we can hear you now. Yeah, we can hear you now.
Yeah. So it's double exponential.
Which kind of exponential? We should be going for double exponential smoothing, and why is that?
Because it has an upward trend, linear upward trend.
It's got an upward rising trend, right? Therefore, I need to go for a double exponential smoothing, right? So I'm going to explain the Holt-Winter methodology for double exponential smoothing now. This is one of the most famous exponential smoothing techniques, or the most widely used technique which is used. This is known as the Holt or the Holt-Winter methodology. Anybody heard of Holt-Winter methodology? Anybody heard of Holt's linear exponential smoothing till now today? Anybody? Arup, you heard of this before?
Yeah.
No? Okay. So I'm going to explain it, and all of us are going to do it on Excel as well. What happens in Holt's linear exponential smoothing is that we have two kinds of smoothing done, and we combine it together in the forecast. One is the level and the other is trend. Right? And I'm going to ask you to do this on Excel with me right now. All of us please open the Excel. We're going to create three series. We're going to create one is the level series. The other is the trend of the series. and then I'm going to do is the forecast of the series. Let's create all of these three criteria. Right? Starting value, let's put up this, and the series is known as YT. So YT is simply the same. Right? Now what is the initial starting values of the series? We are going to start from T2. What is T2 equal to? So Gaurav, are you there?
Yeah, I'm here.
Yeah, Gaurav?
Yeah.
Right, you have created this level, trend and forecast. Right? So starting value of trend at time period 2, what is trend equal to? What should I do with the starting value?
So Y2 minus Y1. So
let's go back here, which is equal to Y2 minus Y1. B2, right? And level? What is level?
It's Y2. Level is Y2.
Level is Y2. So let us give it equal to B3. Got it?
Yes.
Right? Everybody do this. Then forecast starts from S3. S3 is L2 plus T2. Right? So I go over here and just simply do L2 plus T2. Got it? Yeah, Gaurav, is it done till now? Everybody please do this. So I want everybody to do this step by step on Excel so that we can all go together. Any doubts till now? Does anybody want me to repeat anything? Arup, it's done?
Yeah, no, actually, I do have some problem in this Excel. I guess it's an old version, very old actually. So I couldn't do the earlier things.
Okay, let's have. That's Excel 2003, is it? You should be able to do it. I'm going to explain it again. Right? Right? We're going to start off with the time period 2. Let's create level, trend and forecast.
Yeah.
Right? 3 new columns. At time period equal to 2, let's go over here. Don't look at row number 3 because this contains the header we need also. So look at period 1, 2, 3 and so on. At period 2, you're going to go and say trend is Y2 minus Y1, which is Y is the series. So Y2, which is this, minus Y1, which is this. So B3 minus B2. I'm going to put it over here. Level is equal to Y2 itself, like this. Right? And then finally, S3 is equal to L2 plus T2. S3 is over here, forecast at time period 3 is this plus this. So now is it done, Arup?
Yeah, let me just do it now. Your Y is actually something else in here. So trend, first of all, I have to level 2. If I put in level 2 is equal to
T is Y2 minus Y1, L2 is equal to Y2. Just have a look at my formula over here. Trend is B3 minus B2. Trend is equal to Y2 minus Y1.
First of all, we have to fill trend, right?
Okay, Gaurav, sorry, Arup, have a look at my screen again. Arup?
Yeah.
Arup?
Yeah.
I'll do it again. Look at my screen, I'll show it to you again. Okay?
Okay.
Right? Now, level is equal to the current value of the series itself. Trend is equal to the current value minus the previous value. Like this. And forecast at time period 3 is the summation of these two values, level and trend. Okay? Now do this. Gaurav, is it done?
Yeah.
Malikarjun, just put it on chat if it's done. Yeah, Osama, were you able to do this? Malikarjun, is it done? Yeah, Osama, were you able to do this?
Yeah, I've done it.
Okay, excellent. Swadhin? What about you, Swadhi? Are you done?
Yes, I've done that.
Okay, Vinod, how about you? Vinod, are you there?
Yeah, Vinod, just unmute. Yes, yes.
Hello, Vinod? Okay. Done,
Hello.
right? Okay.
Yes, done.
Yeah, we can hear you now. Okay, perfect. Right? So now let's pay attention. How do we do the next part of the exponential smoothing? Now we're going to apply the exponential smoothing separately to level and trend. Right? So level becomes alpha times y2 plus 1 minus alpha times. I'll just have to mute. Yeah. Right? Now please pay attention here. I'm just muting the other people involved. I want all of you to try this. Okay. Right? Let's try this. Level is equal to alpha times of yt plus 1 minus alpha times the forecasted value of the series. So I'm going to put alpha is equal to 0.2 again. Right? Let's have a look. This is alpha times yt. So let's say 0.2 into yt plus 1 minus alpha is 0.8 into the forecasted value of the series at this particular time period itself. Everybody please do this. Please generate the value of alpha like of level equal to like this. I'm going to put this into the chart window as well. Next, please generate this. I'll again put this full formula also over here on the chart window so you can refer it again and again. Right? Generate the formula again. I'll repeat this. Just 0.2 into the value of the series plus 0.8 into the forecast which has been created right now. Okay. So Gaurav, is it done?
Yeah, it's done.
Done. Arun? Osama, is it done?
Done.
Okay, perfect. Swadhi, what about you? It's done. Perfect. Vinod? Vinod, any problems? Okay, Arun, how about you?
Actually, I had problem in the past, so I couldn't continue actually. Hello.
Okay, I'll take it. I'll take
Please
it
carry on.
later. Yeah, I'll take you through it a little later. Yeah. Okay, now let's look at the trend part. Again, look at the formula which I've pasted over to the chart window. Right? In beta. So I'm going to use beta again as equal to 0.6 again. Let's say, so we took, 0.2 as the alpha. So we'll take 0.2 again as the beta, which is, let's say, 0.2 into L of t minus L of t minus 1, which is going to be the difference between these two, which is 0.2 into the difference between the current and the previous trend, plus, which is 0.8 into the previous trend. So I'm going to do is 0.8 into the previous trend. Right? So I'm going to do this. Right? All of you please do this formula. 0.2 into the distance between the current and the previous trend plus 0.8 into the previous trend itself. All of you please do this. And then forecast, the next forecast is simply the summation of level and trend again. Okay. Now what I can do is I can actually drag down this particular formula throughout. Just drag it down all the way to this particular point. So Gaurav, is it done? Yeah, Gaurav. Have you managed to do this?
Yes, Karan, it's done. Yeah,
Right, then I got managed to drag it down. So let's have a look at. Yeah, this one.
Karan, I got distracted. Could you tell me the formula for the next level? Last formula that you got.
Yeah, I'm just pasting it into the chart window again. Yeah, paste it. Let me paste it again. Osama, I think it didn't copy correctly. Ignore that. This is the chart which I'm done. Yeah, Osama, you can look at this one. Right. So now let's have a look at y and the forecast value and see what kind of smoothing do we have. Right. So again, the smoothing looks the same, right, as single exponential smoothing, but the difference will come now is when I drag this down into the forecast period. Right. Now I want to drag this down into the forecast period. The only thing is I need to change the formula a little bit. Right, I'm going to change this formula, which references this empty cell to the previous forecasted value itself. Right. Now I'm going to look at what my forecast looks like, which is continuing the upward rising trend over here. Right?
Karan,
visible to you?
Yeah, it's visible, but I was able to understand everything until you extended the data set from row 145. What did you change there?
Let's go ahead. Right? Whenever I'm doing the forecast for this, level part, right? In the level part, in the end, what is happening is that this formula is always taking the current value of the series and the current forecasted value also. But from this point onwards, right, it will start referencing to an empty cell, right?
I see. Okay.
Right? So if I change this reference, that I don't have this value, but I have the forecast value over here. So I change it to the forecast value over here. Right?
Correct.
So I just change it from this point to this point, so this becomes the forecast. And then I drag the formula down throughout. I don't change anything else. I drag everything down.
Okay. I see. Okay, makes sense.
Right?
Thank you.
So I can get the forecast value out. Got it?
Yeah.
Right? So now my series starts showing a linearly upward rising trend. Clear? Mallikarjun, are you also done? Swadhi, how about you?
Yeah, done that.
Done, perfect. Vinod? Right. Now this is the forecast of the series that I've got. Now is this a good forecast or a bad forecast? Anybody? Is this a good forecast or a bad forecast? Yeah, Gaurav?
Yeah, I think it's a good forecast.
Yeah, but what about the seasonal fluctuation? Right, I need the seasonality also.
Yeah, that's right. There is no seasonal here.
Right? So what I'm going to do is, I'm going to create something known as a seasonal index. Let's call it seasonal index. Create another variable in the column and call it seasonal index. Right? And what we're going to do is we're simply going to subtract from y the forecast from y. Right? Just make it subtract the forecasted value from the seasonal index. Sorry, from the original value. And let's drag it down all the way till the point we have data. only till the point we have data. Nothing more, nothing less. Right? So I'm going to do it, drag it down all the way till the time we have data alone. Right? How will this help us? Anybody? Now I'm going to do a very interesting thing, which is going to call it the season period. Right? Till this point, is it done, Gaurav?
No, I'm
Did
just
you create the seasonal index?
I'm still creating it.
Right?
P4 minus
Yes.
P4.
So create the seasonal index. Create the seasonal index as the difference between the original series and the forecasted series from the Holt vector method. Holt method. Right? And drag it down all the way for the time period we have the data for. So go only till 144 and not beyond that.
Okay.
Only
Yes,
till
done.
144.
Okay.
It's done. Right? Now next to it, I'm going to create the seasonal period with simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And after that, I'm going to start off again from 1, 2, 3, 4, 5. Right? So I'm going to just simply tag that what part of the season is this at. Right? So create a repeating number 1 to 12 which goes down all the way. Right? So only till this point I'm going to delete all of this. Right? Create a seasonal period which goes 1 to 12. Okay? Malik Karjat, is it done? Yeah, Malik Karjat, is it done? Just create. So what I'm doing is I'm just doing recursion. So I write down 1 to 12 over here. And after that, I simply write equal to G4 and I drag the formula down. So that I don't have to keep doing it manually. Right? So Adil, what about you? Have you managed to do this?
Yeah. I've done that.
Gaurav?
Yes, it's done, Karan.
Okay. Gaurav, it's done. So what I'm going to do now is I'm just going to introduce a pivot. So look at my screen now. I select column F and G. I insert a pivot table over here. Right? Now in this pivot table, I look at the seasonal period over here and I look at the seasonal index over here and I calculate the average value. I change it from count to average. Right? That what is the seasonal index at period 1, 2, 3, 4 to 12? What is the average over here? So I get this average out. Right? Now I want everybody to pay attention to my screen and then do it on their own. Right? What I did was I simply took a pivot out. That for all period 1, the average is coming out to be minus 61. For all period 2, the average is coming out to be 515. For all period 3, it's coming out to be 1101 and so on. Right? So this is what the average index looks like. I copy it. Right? I let it be over here. Then I want to forecast what this index is going to be like at this particular point in time. Right? I need to forecast what is the average index is going to be like. Right? So I just say, this is going to be, first of all, I need to figure out what time period should I be forecasting it for. So this is period 11, period 12 and so on and so forth till this particular point. Right? Then I use a simple VLOOKUP to get what is the seasonal index at period 11 and so on. So I just do a VLOOKUP over here. I lock it. I say the second column false. Right? It says that period 11 it should be minus 2623 and so on and so forth. Right? Now I build the actual seasonal forecast over here. So seasonal forecast is going to be how much? So this is always the difference between these two, right? So the seasonal forecast will simply be the summation of the Holt vector plus my seasonal index. So I look at this now and I call this particular series as my forecast with season. Right? So let me now plot these two together. I'm going to plot the original series Y and the forecast series with the season over here and see what it looks like. Right? So can all of you see that I have also captured the seasonal fluctuation to a degree?
Yeah.
Yeah. So Gaurav, how does that look? Does this look much better?
Yes. Yeah. Yes.
Mallikarjun? Okay. So now, so Swadhin, are you clear how I went about doing this?
Yes.
Right? What I did was, I first used the Holt Winters method to get the forecast out. Then I calculate the difference between the original value and the forecast. So this gives me a sort of what is the seasonal index looking like, right? So I see that it is repeating every 12 months, right? But look out, what is the 12-month average of this looking like, right? That I did by using the pivot index. So I looked at a period of 12 months, the average fluctuation of the series is coming out to be this much. Right, Swadhin?
Yes.
Yes, Swadhin, are you there? What I did
Yes,
was once I
I'm
got
here.
the
I'm
average, I
here.
simply added it back to the so once I got this average out, I simply added it back to the forecaster that I generated using the Holt method, and I got my seasonal forecast over here. Right? So using simple Excel, what I've done is I've used exponential smoothing to forecast the trend as well as the seasonality also, and generated a forecast like this, which looks, well, at least on the graph, it's looking pretty nice.
Yeah.
Right? Any questions, any doubts? Right? What all of you can do is you can try doing this on your Excel sheets on a different data set. What I'm going to do now is I'm going to introduce how to do this on SPSS now. Any doubts before we move on to SPSS? After this is going to become very, very easy. So what I've done is I've shown you by hand how SPSS actually does it in the background. Right? Now we're going to automate this procedure. Right? Any doubts, any queries till now?
Just one query from my side. Just one query from my side. On what basis we choose alpha?
Go ahead.
On what basis we choose alpha?
Alpha is supposed to be chosen between 0 and 1. So if you choose a high value of alpha, what will happen? Right? So we covered this earlier, right? A high value of alpha, what does that happen?
High value of alpha
will give you very little smoothing, right?
Yes.
Will give you very little smoothing, right? In that case, you will not be able to capture the seasonal fluctuation.
Yes.
A low value of alpha will give you much smoother value, but a low value of alpha gives higher weightage to the past value of the series and less weightage to the current value of the series, right?
Yeah.
Right? So when I use a low value of alpha, I say, let's say I take alpha is equal to 0.1. That means 10% of the smoothed value is coming from the current value of the series, 90% is coming from the past.
Yeah.
Right, Swadhi? On the other hand,
Yes,
if I say 0.6 as alpha, that means 60% of this value is coming from this value and 40% is coming from the past using the exponential decay.
Yeah.
Yes. So value of alpha is left up to you, whichever one you want to feel, you want to keep changing. So what you can do is actually in this particular sheet, you can change the value of alpha also and see how does it change your forecast.
Okay.
Yes?
Okay. It's based on your own judgment.
Typically, the value of alpha is about 0.1 to 0.3.
Right. Got it.
Okay. In case if you have a seasonal data set, then you use low values of alpha. If you have a non-seasonal data set, you're only interested in capturing the trend, then you can use alpha of 0.5 and 0.6. Okay?
Okay.
Okay. So I'm just going to launch SPSS now. I want everybody to launch SPSS. IBM SPSS statistics. So Swadhi, have you installed SPSS?
Karan, when your the training session gets over, can you please send us this Excel sheet, the one that you just made?
I'll send you the sheet with the calculations. The calculation rule that I skipped, that you can also try it out. The actual intent is that all of you should be actually be able to do it on Excel also, because the concept behind this is very, very simple. Right? It's a very, very simple concept behind this. We don't actually need a software to do forecasting. You can have a simple forecast like this. You can simply hold the method and do it. Right? All of you quickly import the dataset into SPSS the same way we did it last time. File, open, data. And the same dataset. I want all of you to open the same dataset, the retail dataset. I'm going to do it as all files over here so that it becomes all files. And retail to load Excel. So it's already open in Excel. So one thing, just save this file as a separate file. So don't overwrite, otherwise you will lose the original data. I'm just going to save it as something else. Retail to let's open it again in Excel. Open your data which I have sent across, which has got the period and the sale. And also please do this. Okay, Arup, do you have SPSS installed?
No, sorry, actually. I fixed to my mobile actually, so it was a huge file, so I couldn't download and install actually.
Oh, okay. So how are you able to watch my screen?
Yeah, I can watch your screen. I'm watching everything. I'm getting a good watch.
Okay. Gaurav, how about you? Is it important? Malik Arjun, please do it. Swadhi, do you have SPSS installed? Were you able to get SPSS? Yes, Swadhi?
Yes, I cannot download the SPSS. Hello?
You were not able to download?
Yeah, I was not able to download, but I'm seeing your...
Okay, in that case, what you do is just... Yeah, you can just follow me on the screen instead.
Yes.
Yeah, Vinod, how about you? Yeah, Vinod? Okay. Malik Arjun, is it done? Just type in if you imported it. Gaurav, imported?
Imported.
Okay. Right. So let's start off. The first thing that we have to do when we are working with time series data is that we've got to do is to define date format so that we know that we are working with a data set which has got a time component to it. Right? So what I'm going to do is I'm going to go to the data format over here. Right? There is a data tab. Within data, there is an option called define dates. Right? So I'm going to say that this data set is working on months and years. Right? So again, I'll explain it again. Please follow me. Go to data. Within data, there is an option called define dates. Please click on define dates. Everybody please do this. Data and then define dates. Right? And I'm going to say that this within date, select years, months. There is an option called years, month. You will say that this is year starting with year 1999 and month is 1. Right? Press OK. So we can see that we've got data from January 1999 till December 2010. Right? I want a forecast after that. Right? Till this point is it done? Just confirm again. Gaurav, Malikarjun and Vinod, those who are doing it on SPSS, please confirm whether it is done.
Yeah.
Malikarjun, just
Yeah,
type
it's
it in.
done.
It's done, Gaurav?
Yeah.
Malikarjun,
Yeah.
just type. Vinod, you can also, if you can type and let me know if it's done. Malikarjun, is it done? Define dates is done? Okay. In the next part, now what we're going to do is we're going to do the analyze. Please go to the analyze option over there and go into forecasting here, right? And say there's an option called create models over there. Please go to analyze, forecasting, create models. Right? Over here, the dependent variable is going to be sales. We go to predict sales. Just click sales over here and bring it into the dependent variables option. After that, there's an option called method over here in the below bar. This is method. We are not going to use ARIMA or expert modeler. We're going to use exponential smoothing over here. So click on exponential smoothing. Right? And click on criteria after that. Right? So which criteria should we be going in for? So again, so Arup, right? Which criteria should I go in for? Yeah, Arup, are you there?
Yeah, I'm there. Holt's linear trend.
So if I select only Holt's linear trend and I press continue, right? And I press OK. What happens? See what the photo looks like. I'm getting a series start. I haven't got a forecast. Let me do it again. I'll go to analyze again. I'll generate a forecast also over there. The forecasting three models. Criteria was Holt's linear trend. Right? I'm going to do plot is in the plot I'm going to do is the forecast as well as the observed value. And the option I'm going to generate a forecast for 12, let's say 24 months. So I've got data till 2010 pulses, generate till 2012, month 12. Now I've done. Right? So what is wrong with this forecast? What have I done? So Arup, is this similar to the forecast that we also generated? A simple straight line? Hello? Yeah, Arup, Gaurav, are you there?
Yeah, I'm here. I think that's the one that just got now it is not correct.
The
It is a non-seasonal model, right? We
Yes,
did not capture seasonality, we only captured the trend.
correct. Yeah.
Right? So how do I capture the seasonality as well? So let's go back over here. Right? I'll just delete this forecast so that we don't have to be working with this. Yeah, let's go over there. So I just go here, analyze, and say forecasting, create models. Right? Again in the criteria, instead of Holt's linear, I say I build a simple seasonal model with periodicity 12 now. Right? Now I press it.
Yeah.
And now I get a seasonal model, right? Now what's the problem with this? The problem is I'm getting a flat trend here, right? I've captured the seasonality, but the trend is not correct.
Yeah, trend is not there.
Yeah.
Right? Trend is not correct. In this case, seasonality is captured, but trend is not correct. So this is where we use something known as the winter method or the Holt winter method. Right? So this is known as the Holt winter method. The one which we did on Excel. Right? So the Holt method will capture the trend and the winter's method will capture the seasonality. Right? So the third time lucky, if I'm going to do this, I'm going to go to forecasting, create models again. In the criteria, instead of simple thing, I'm going to say winter's additive. This is known as the Holt winter method. This is going to combine Holt's linear train and the seasonal component and call it Holt winter method. Press continue, press OK. And this time I see I've got the trend as well as the seasonality, right? Something similar to what I did on Excel over here. Right? So this over here we captured only one season, but in SPSS we generated it for 2 seasons. Right? Obviously SPSS is going to be slightly better than what we did on Excel. Right? But the methodology remains the same. Right? All of you please do this in your SPSS. I'll show you the options again. Go to analyze. There's an option called forecasting. There's an option called create a model over there. Right? Please select sales as the dependent variable. Right? In the method, select exponential smoothing. In criteria, select winter's additive methodology. Right? Then over here in statistics, there are certain statistics or goodness of its criteria which can be used to check how good or how bad your time series model is coming out to be. Right? Then you can generate the plots. We say I only want the observed values and the forecasted values after that. I don't want anything else. Right? In the same option, you can say that if you want to predict the forecasted values of the data set or not, and how long do a forecast do you want? So over here I say year 2012, month 2012. And I press OK like that. Right? Again I get the forecast out, I get all the goodness of its criteria. In the data set which I have now, if I scroll down, right? After that I'll get the 24 month forecast also generated over here, just like I did on Excel. In Excel also we generated the forecast, here also we have generated the forecast. Right? So any doubts, any queries till how we're doing it on Excel, then how do simply do it on SPSS as well. Yeah, sorry, were you able to follow?
Yeah.
Okay, excellent. How about you, Mallikarjun? Gaurav, any doubts, any queries?
No.
Were you able to follow on SPSS also how to generate a forecast?
Yeah, I was able to follow the SPSS.
Yeah, Arup, so about the Holt. So Arup, are you comfortable using the Holt linear method now?
Yeah. It's pretty easy in SPSS.
Perfect. It is much easier. In SPSS you only have to click your way through. So for 2 hours I was expecting how to do it on Excel, but if you have SPSS, you don't actually need it. Right? So the objective of doing it on Excel was to show you that it is not very complicated. One can do it by hand also. Right?
Yeah.
Provided you understand the concepts of exponential smoothing. Right? So if you understand the concept of exponential smoothing behind, right? So you can see that how I've generated, looking at this graph, I've extrapolated the trend, then I extrapolated the seasonality and I combined it together and I got a forecast which looks very nice on paper on Excel at least, right? So I don't need SPSS, but if we do have SPSS, we can actually do it very easily. Right? So what I'll be doing is I'll be sharing the recording of the session to all of you involved. So what you can do is actually go back and do it on your own systems as well. A few more data sets. So I've got another data set over here. Let's try and look at this. So I want everybody to tell me what methodology and which model to build over here. So I'm going to look at the cyclic airline. So this is a very famous data set. Right, the data set is over here. And I'm going to generate a graph. Chart builder. Let's have a look at this. I want a line chart. So just 5 more minutes there. Passengers on the y-axis, months on the x-axis. That's okay. Okay. So does this graph look like a random walk? First question. So Arup, is this a random walk or can I do time series analysis on this?
No, it has a trend actually.
It has a trend and it has got a seasonality, right?
Right. It has a trend and seasonality.
Right? So we're going to now forecast this for 12 months. I want you to tell me the option which I should use. I go to analyze, forecasting, I want to create model. I drag passengers over here, exponential smoothing criteria. First of all, I need to define the date. So I go back again so that I can build a seasonal model. I go to data. I say define date. Again, it is years and months, right? And it starts from year 1949, month 1. Right? Now I go to analyze, forecasting, create model. Again, passengers is the dependent variable. Methodology, exponential smoothing criteria. This, right? So which methodology should I go in for? Which option do I click over here?
Winters editor.
So winter and
I go to Winters additive. Again, I go to the Holt Winters model. I use Holt Winters additive. Right? And I want, let's say this goes till which year? Just check it out. I've got data till year 1960. So let me say I want to generate till 1962 on 12, and it's okay. And here I get the forecast out. Right? So it looks like the trend has been captured, and the seasonality to a large extent has also been captured, right? You know, the difference is that in this case, we are not going for a relative seasonality, we are going for a multiplicative seasonality. Right? So we should have actually used Victor's multiplicative over here. So I'll explain the difference between additive and multiplicative seasonality sometimes later. So the basic difference is that in this case, we can see that the seasonal fluctuation is multiplying over a period of time, right? It does not remain constant. Right? So Gaurav, if you can look at this graph, right? We can see that the amplitude of the season actually starts magnifying as we go season after season, right? It does not remain constant. Right? In this case, this is known as a case of multiplicative seasonality, whereas in our previous data set, we had a case of additive seasonality. We have a trend, but the seasonal fluctuation remains constant. It does not increase too much, right? Right? So that is the difference between additive and multiplicative seasonality. So in SPSS, we have an option to go for multiplicative seasonality as well. So I can go over here and say that instead of winters additive, I want to go for winters multiplicative. And let's say, I think this is the old data set. Hold on. Yeah, over here. Analyze. Casting, create model. Criteria, I need to go for winters multiplicative. Now in this case, I get a slightly different forecast as compared to the additive model. I can see that my seasonal fluctuation also starts increasing. Right? For the forecasted time period, my seasonal fluctuation has also increased as compared to the previous season. Whereas in the additive model, I had a constant fluctuation. In the multiplicative model, I get a multiplicative fluctuation. Right? So that's the only difference between additive and multiplicative. So in this particular case, it is better to go for a multiplicative model. Alright, so what I'm going to do is I'm going to share this Excel sheet also with all of you involved over here. I'll mail it across. At the same time, I'll upload the recording of the session as well. And if you have any doubts or queries, you can either ask me right now or you can mail them to me across and I'll handle them as well. So any doubts, any queries on basic exponential smoothing for time series? Right? Anything else? I'll just do a quick recap of the decomposition part. So this is the most important takeaway from the session. That is the decomposition of a time series into its constituents. The most important are the trend and seasonality which we covered today. So what do we mean by trend? A quick recap. So what do we mean by trend?
Long-term progression of things.
The trend is a reference to the long-term progression of the series, with which we have removed the short-term fluctuations. So how do we capture trend in a signal? Given a data set, how will we capture the trend?
Exponential smoothing.
Yeah, using exponential smoothing, right? And
Yeah.
when to use what kind? If I have a flat trend, I go for a single exponential smoothing. When I have a linear trend, then we go for double exponential smoothing, right? Within double exponential smoothing, we can go for the Holt winter method, right? How do I capture seasonality in the data set?
You subtract your trend minus actual to get the
Right?
seasonality.
If I have extracted the trend, I can subtract the trend from the signal and get the seasonal fluctuation, right? And the seasonal fluctuation, I can simply now look at this and average out the seasonal fluctuation over one time period, and simply use that to forecast it, and then I integrate the series back together to get my forecasted series. Right? So what I did was, I built a seasonal period over here, 1 to 12. So I know that this particular seasonal index now keeps repeating at intervals of 12 months, right? So I simply average it out that over a 12-month period, what is the average fluctuation like? And I use that to do the forecast around the winter's exponential smoothing itself. Right? So that is known as the Holt winter methodology for building a seasonal model as well. Clear? Right? Any doubts, any queries? Anything at all? Any queries, etc. So what we're going to do is we're going to call it a session, we're going to call it a day. And thank you all for logging in and coming in on a Sunday for to attend the session. Any doubts, any queries, you can let me know. Anything at all?
Thanks to you, host. It's really a wonderful exercise.
Okay, thanks for coming in. And what we're going to do is we're going to try and have more of these sessions, and probably I'll either be recording these sessions or I'll be inviting people over. So anybody is free to come in for these specific webinars, and I'll be posting this online, and so you can again revisit this whenever you want. Right? Thank you all for coming. Any doubts, any queries, feel free to mail me.
Yeah. Thanks to you.
Thank you.